Hello, testing 1111. Hello. Hello, testing 1111. Uh, can you hear me? Test, test, test. Can you hear me? Test, test, test. Okay, sounds like everything's good. So I am back. Been a while. I said around 8 o'clock, but family stuff, so now I'm here. So that's all that matters. Oh, my stomach hurts. Oh no. Oh, okay. I could multi-stream. But I don't know how good that would do. Right now, for some reason, I have a couple of viewers. So what's up, guys? What's up? We're just gonna continue on 4.5. And I think this is where we left off here. I didn't really change anything. So if you just came in from the other video, just continue on. I'm gonna just straight up start off the bat here. No delays or anything, so let's get right to it. It's 12:07 a.m. It's gonna be a chill night for tonight. I'm kind of charging up my secondary light so I can get some chill light rather than this thing blazing in the background here. See how long this one lasts. Not yet. It's only 3 bars. I need to hit 4 for it to be full. Oh. I got my tea over here and we are ready to go. Alright, let's start off. 4.5 loop examples iterating n times. So a quick refresher here. Let's go back to looping n times. A loop commonly must iterate a specific number of times, such as 10 times. A loop iterating a specific number of times. A loop commonly must iterate. So it's a common thing that a loop iterates a specific number of times, such as 10 times. So setting a certain loop a number of times is a common thing in the industry, I'm assuming, or a programmer does. A loop iterating a specific number of times commonly consists of 3 parts: a loop variable initialization, so the conditional statement that has a variable assigned with an expression. So I is assigned to 0. That would be for the loop initialization. Decision statement with a loop expression. They call it a decision statement. With the loop expression. Oh no, this is the decision statement. This would be called an assignment statement. This would be decision statement. And a loop. I dropped my pen. Sometimes I like to look at the camera and see if I got any boogers in there. A decision statement with the loop expression and a loop variable update. The loop expression and a loop variable update at the end of the body. I plus I plus 1. An assignment statement. I is assigned with I plus 1. Then it goes by how many times. Da, 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 da. Following program outputs the amount of savings account. Oh, I think we already did this, right? All right. Let's continue on here. It just keeps going, I'm assuming, right? Yeah, okay. We're getting to the good part. We're just getting a little bit more examples. Finding the max. Analyzing data is a common programming task. Common data analyst task is to find the maximum. Didn't I do this? I feel like I did this. Or maybe I stopped at this point. We'll just start all over. Analyzing data is a common programming task. A common data analyst task is to find the maximum value in a list of values. A loop can achieve that task by updating a max seen so far variable on each iteration. So it can achieve the task by updating a variable on each iteration. Consider the example above. Before entering the loop, what is the maximum value seen so far from the list of integers? Yeah, I did do this. I'm pretty sure I did this. Because I remember this tricked me earlier, if I can remember that. We're entering the loop. What is the maximum value seen so far from the list of integers? So from the list of integers, we have max so far, which is 0. Num values, which we get 1 value out of it. What is the maximum value seen so far? Get the next input -1. Before the loop, no list has been input yet. No max value seen so far. Because we didn't start the loop, is that the reason? Before the loop, no list items has been inputted yet. Get next input -I, or -1. Before the loop, no list item has been input yet. And a list of values. Right here, it's I would be the zeros less than 4, which is true. Current value, you get the next input, which is -1. The curve value is -1. I would be 0 is equals 0, which is true. So max so far is assigned to current value, which will be -1. That's the maximum value seen so far. So what does this say? Max value variable was initialized to 0 for safety, but before the loop, No value from the list has been seen yet. Oh, okay, that makes more sense now. The max so far was initialized to 0. So that's the only time we've seen it, but before the loop, there has been no value from the list has been initiated, meaning that it has not been calculated yet. It has not started. Gotcha. The loop's first iteration gets the list's first integer into variable curval. Is the max value seen so far? Curval. Wouldn't I say yes? The first val is the max value seen so far. The first val is the max val, as well as being the minimum val seen so far, because it's the first, right? The if else statements I equals 0 branch. If else. The if else statement I equals 0 branch detects that this iteration is the first. It detects that this iteration is the first and simply assigns. I detects that this iteration is the first. So the first iteration knows that this is going to be the first thing to find the maximum value in the list. What do they mean by that? The if else statement I equals 0 branch detects that this iteration is the first. First being true, so it detects that it's a true statement and simply assigns max value. I think that's what they're trying to say. First iteration. And so in this decision statement, I equals 0. I think it's 0, right? 0 is less than num vals, and earlier num vals was 4. So that's true. So that makes 0 equals 0, which is true. So it detects that being that statement being true, which will turn into, which will follow along with what did I call it, like the Boolean branch or something. It would just follow along with the true branch, making it to be inside the list, creating the first maximum and minimum value for max so far. And that's what they're trying to say. Okay, sure. For each iteration after the first iteration, comparison. Max so far curve value. For each iteration after the first iteration, the comparison. Max so far greater than curve value? Or is it max so far is assigned with curve value? After the first iteration, comparison. I don't want to look at the answers. I want to understand what the question's asking. For each iteration after the first iteration, the comparison is checked. For each iteration after the first, what is always checked? I equals 0 or I is less than num vals. But they only given me is max so far is greater than curve, which I don't see that, so that's not true. Curve val is greater than max so far. Curve value is greater than max so far. I see that. But I don't see equals at all either. So that's not it. So they kind of like narrowed the answer for me. But if the question's asking me, or the statement's asking me for each iteration after the first iteration, the comparison for each iteration after the first iteration, the comparison. The comparison curve values greater than max so far is checked. Well, it does have a Boolean statement here. And it's also a decision statement, right? It's another decision statement. So there's 3 decision statements. So it is checking for something, right? It's considering that it has a true and false statement. Curve value is greater than max so far. I am tired. After the first iteration, I equals 0 will be false. That's just by knowing, right? I will be 0. So the else if expression is checked. Else if expression is checked if the current value is greater than the max seen so far. If the current value is greater than the max seen so far, then that current value is the new max seen so far. And that would be the, let's see, they're assigning it. The curve value is the new one. So the else if branch executes da da da. Beyond iterating n times. By adjusting the 3 parts of a loop iteration n times. Now, what is the 3 parts of the loop iteration? It would be the initialization, which is I is assigned to 0. That would be the first one. Obviously, I know the last one would be also another assignment statement, which would be I is assigned to I plus 1, depending on how the program's set up, right? But I'm assuming it starts with, you know, as a basic person understanding programming, it'll say plus 1. You know, to continue the iteration until it finds its until it finds a sentinel value, and then it'll stop the loop iteration. But the middle one, we got the name of it, but I'm assuming that it just tells you like, okay, you're creating the loop body, and so you have like a list of statements, which will be your iteration, right? You're iterating in your loop body. That would be the second step in order to create a loop. Okay, anyways, a loop can output various sequences. The following outputs multiples of 5 from 10 to 50. Multiples of 5. So it starts, instead of starting with 0, it starts off with 10. So if 10 is less than or equal to 50, which is true because it is less than 50, it'll put it to I, space, and then you're updating the loop variable, which is I is assigned to I plus 5. And so it'll be what, 15? We'll just keep iterating by fives. We'll watch it. Take a look at it. Take a look at the variable section. It's going up by fives because it's hitting the loop variable update. So it's checking on the loop expression. Beyond iterating n times. Type the output of the loop. White space matters, including after the last item. What? Type the output of the loop. Oh. We'll start with 2. What do we have here? We have a loop variable. We have a 1. 1 is less than 7, which is true. Put I, put space, and then you're iterating. You're updating actually the decision statement or the assignment statement. I. You're adding a 1 to it, so it's now a 2. 2 is less than 7, so you're putting another I, space, and 3. 3 is less than 7, put another I, space, 4, put another I, space, 5, another I, 6, another I, 7. It's an equal sign, so it's equal, so you can put another I. Now it's 8. It's not greater than or equal to, so that should be it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Oh, do I have a space? One, 2, 3, 4, 5, 6, 7. Yeah, I have 7. No shot. There's a space. Oh, wait. Do they want me to put the number? Oh, they want me to put the number. You always have to pay attention because I think it's a string and it's not a string. Searchable and due to. There we go. Yep. We got a lot. Let me do number 5. We have 5. 5 is greater than or equal to 0. That is true. 5 space minus 1 4. That's true. That's true. That's true. That's true. That's true. 0 is true. I space. Outputting a table of temperatures. Programs are sometimes used to auto-generate data tables. The following program generates a table of Celsius and Fahrenheit temperature values in increments of 5 Celsius. The loop counts from -10 to 40 in increments of 5. And it names the loop variable curc rather than I to be more descriptive. Loop initialization, same thing, so they're just adding more vocabulary to it. What is the loop variable name? While the loop variable could have been named I, the name currency current Celsius is more descriptive, helping a reader better understand the program. Current Celsius. What are the values of currency for the first 4 iterations? What are the values of currency for the first 4 iterations? What are the values of currency? It's a little faster. What are the values of currency for the first 4 iterations? Negative 10, 5, 0, 5. Negative 10, 5, 0, 5. Currency is initialized with negative 10, and the update amount is plus 5. What is the loop expression? Isn't that the loop expression? The expression checked for whether to enter the loop body. Easy. The loop will iterate with currency of 40 but not with 45. The programmer could have written currency is less than 45 or 41, but less than or equal to 45 approach is more explicit, making clear that the last value considered is 40. Note that this expression differs from the second approach when merely looping n times, which starts with I is assigned to 0 and then has expression I is less than n. This expression differs from the standard approach. Okay, I see what they mean. Okay. I just wanted to think in my head what would not be, what's the difference between that and the one with the i's assigned 0 and expression. I think it's just because of a different operand. Is that the only reason? Like it's this one's more specific, making it explicit versus something that's just less than the number. Like we don't want it to be equal as well. Okay, finally we get to some while and for loops. Now I'm pretty sure I've written it somewhere here. I have to look for it. Yeah, okay. Okay, so while loop. So the only key things I took away from while and for loop, before I read it, is that it's event driven. While loop is more of an event driven kind of thing. So like if it's iterating till the input is like a certain number, certain variable, whatever the input the user wants to put in until it hits that exact input, it's just gonna keep iterating. For loop is like aware of the number of iterations. It exactly knows how many data elements is contained while is contained. WI. Oh, within. Okay, no wonder. How many data elements is contained within that array or list? So if it exactly knows how many data elements is contained within the array or list, example, iterate to 100. Okay. So let's read it. Hopefully we can understand a bit of it a little more. But I do know the difference when I look at it in code. Just understanding it a little bit more might help me. Don't they have loops? This is in C++. Before we read that, we'll start off with, oh my god. Okay. Sorry, I was making a drink. 4.6 while and for loops. While and for loops, because looping until done and looping a certain amount of times are so common. Most textual programming languages have specific constructs for these types of loops. Where's my pen? Oh. while loop is a loop that repeatedly executes the loop body while the loop's expression evaluates till true. Oh, I understand that. So while the loop's expression evaluates the true. While the loop expression is true, it'll keep looping the loop body. That's how I wrote it. It'll just keep looping as long as the loop expression is always true. A for loop is a loop consisting of a loop variable initialization. So a while loop doesn't have a variable initialization. I'm pretty sure they'll give us an example. I like that my phone is the camera because then it would it prevents me from being distracted. But I don't have a phone. Can't really randomly pick up my phone and just start scrolling, you know? Um, a loop is a loop consisting of a loop variable initialization, a loop expression. So it has a loop expression as well, but it also has a loop variable initialization and a loop variable update that typically describes iterating for a specific number of times. Loop expression. And loop variable update. Generally, a programmer uses a for loop when the number of iterations is known. So if you know how many times you want to loop it, you do a for loop. Like loop 5 times or loop, yeah, that's what I was just saying, and a while loop otherwise. Or number of iterations is computable if you for the loop, like iterating a number of times. Number of iterations not easily computable before the loop, like iterating until input is Q. Okay, choose the most appropriate loop type. Iterate as long as user entered integer C is not 0. Wait, what? Iterate as long as user entered integer C. As long as C is not 0. As long as C is not 0. Would that be a while? The iterations are not known before the loop. Yeah, we don't know. A while loop is preferred. Iterate until the values of x and y are equal, where x and y are changed in the loop body. Iterations are not known before the loop. Oh, so it doesn't matter even if we have a until x and y are equal. Okay. So I guess as long as it gives us like an actual number, then it would always be a while loop, I'm assuming. So number 3, like I'm assuming that's a for loop, right? Okay. Nested loop. A nested loop is a loop that appears. Hold on, let me write. The loop that appears in the body of another loop. Um, I'm assuming this is the nested loop, so it's the second decision statement. 1, 2, 1, 2. Okay, so I kind of made it right. Mine's a little smaller, but hey, close enough. A nested loop that appears in the body of another loop, the nested loop are commonly referred to as the inner loop and outer loop. Nested loops have various uses. Below is a nested loop example that graphically depicts an integer's magnitude by using asterisk, creating a bar chart. The inner loop is a for loop that handles the printing of the asterisks. Now, for loops are, if we can remember, for loops are loops that we understand how many times we want to iterate. So that's how we know it's a for loop. How do we know it's a for loop? It starts with initialization, which is a decision tree, and then it starts with a, well, I know the ending. I forgot the middle. What is the middle? The loop expression. Oh, so initialization, loop expression, and an update. As long as you have those three, then it's fine, right? And this is a while loop, I'm assuming, and then this is a for loop inside a while loop. The inner loop is a for loop that handles the printing of asterisks. The outer loop is a while loop that handles executing until a negative number is entered. How many questions we have here? We'll do number 2. What is the output by the following code? Oh, I actually have to do this? Okay, well. Rows to 2. 2 is less than 4, but just true. So call is assigned to 0. So you have a while loop and a for loop getting ready here. So you have a call is assigned to 0. 0 is less than 2, which is true. Put row to output. Put call to output. Oh. Gotta remember that's not a string. Put row to output, so we're gonna put 2. 0 space, and then call is added plus 1, and we know call is 0. So now it's 1's less than 0, and then now we put row again, and then call, we know call is 1, and then we add plus 1 would be 2. 2 is not less than 2, so we leave out of that. Then we go row plus 1. We do know that row is 2, so we add 3. So 3 is less than 4. So then we go to call one more time, and call will be assigned 0 one more time, and call will be less than 2. So then now we put I think we do the same thing, right? Call is less than 2. Oh wait, put row. Isn't row 3? Then call is 0. Space, add 1. 1 is less than 2. And put row again, which is 3. And put 1 space, and it'll be. Oh, I lost my train of thought. 2, so it's less than 2, which is not true. Goes down to row, and 3 plus 1, 4, which is not true, and it ends. There we go. Now we understand nested loops. As long as it has the initialization, the loop expression, and the loop variable update, it's good. That's a while loop because it doesn't have a loop initialization. Kind of easy to spot it out. While loops. Oh, so okay. So we're just gonna only talk about while loops now. It's something to hold. Okay, much better. Alright, 4.0 code while loops. In code, a loop can be written as a while loop. A while loop repeatedly executes the loop body while the loop's expression evaluates to true. Well, finally, we got some code. In code, a while loop uses the word while followed by the expression. The loop's body statement starts on the next line and are indented. So that's how we know it's inside the loop. The expression is true, the loop body executes. After executing the loop body, execution jumps back to the while loop's condition. When the loop expression is false, execution proceeds to the statement after the loop. How to write notes. Loop expression is false. Okay, we got that. Use a single operator in each loop expression and the most straightforward translation of the stated goal in the expression. While it's a loop statement. Alright, while x is less than 100. X is greater than or equal to 0. User num is not 1. Oh. -1. Below is a while loop example. The program asks the user to enter a year. The program asks the user to enter a year and then outputs the approximate number of a person's ancestors who were alive for each generation leading back to that year, with the loop computing powers of 2 along the way. So everything here is inside the while loop. What did I just do? What did I just do? So everything here is inside the while loop. Let's go back 1 generation. You're going by current year. It's going to be assigned to current year -20, so it'll be 2000. Then it'll be the next input, whatever the person puts back. they will be here for a while if I just keep going. So yeah, look how fast. Consider the example above. The loop body updates the current year. Loop body updates the current year. Per year. Per year was initialized with 2020. Each loop iteration decreases by 20. So that's the update that they put in. So what do they call it? They just call it an assignment statement? Hmm. The user has to enter a value at the end of each loop iteration. The user has to enter a value at the end of each loop iteration. No. Only enters one value before the loop begins. The loop executes while current year is still greater than or equal to user year. Each loop iteration outputs the current number of ancestors. Each loop iteration outputs the current number of ancestors and then doubles the number of ancestors in preparation for the next iteration. So let's find the first statement. Each loop iteration outputs the current number of ancestors. Current year, number of ancestors. Answers at 2. And then doubles number of ancestors. It's true. In preparation for the next iteration. Updating a value in each iteration is a common pattern. The user inputs 1940 for user year. How many times will the loop iterate? User inputs 1940 for user year. 1940 goes down by 20, so 20,087. Assuming it's gonna be 80 or okay. To be fair, I kind of cheated. First iteration has current year 2020, then 2000, then 1980, then 1940. Oh, if the user inputs for user year. I was just looking at user year and I didn't read it correctly. Will the loop iterate? I just ignored everything here. But you know. My head was there, just didn't read everything fully. If the user's input 2030 for user year, how many times does the loop iterate? See, that's a trick question, because user year, or current year, is 2020, and if current year is 2020 greater than user year or equal to, which is not true because that's 2030. It's not going to iterate. Bum, 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 bum. Yeah, if while or loop. Oh, I ran out of battery. This device. Hmm. Oof. Yeah, ran out of battery. Give me a second. I get this. God, you gotta have like nails of steel to get this out. Okay, so that's charging. Let's see if I can start my Twitch.
But most people still call me needy. You'll see everyone.
How do I go live on Twitch? Prime. Security. Um, I don't think I did it right. Oh God. I gotta figure out the URL for my stream key. I don't know what that means. New York. I think Atlanta, Georgia is the closest one. As I'm live, but I'm not live. Aww. That is so weird. I don't understand. I knew I was gonna find it. It was hiding. It was hiding. While loop executes the statements repeatedly until the value of the expression becomes equal to 0. The test takes place before each iteration. Expression, any expression of scalar type, this expression, I don't know what a scalar type is. It's not going to tell me what a scalar type is. God. Scalar. Oh, here you go. Pointer types. Any expression of arithmetic type. It's in the header. The type of the predefined null pointer constant is a distinct type that it's not itself a pointer type. It can be implicitly converted to any pointer type or boolean. Okay. Any expression of scalar type, this expression is evaluated before each iteration. If it compares equal to 0, the loop is exited. Statement typically a compound statement, which serves as the body of the loop. Attribute spec sequence. Optional list of attributes applied to the loop statement. Alright. Oh, it's the whole thing here. Introduces implementation defined attributes for types, objects, expressions, etc. Attributes provide the unified standard syntax for implementation defined language extension, such as the GNU and IBM language extension attribute, Microsoft extension. An attribute can be used almost anywhere or almost everywhere in the C program, and it can be applied to almost everything. To types, to variables, to functions, to names, to code blocks, to entire translation units. Although each particular attribute is only valid where it is permitted by the implementation. Expect true. Could be an attribute that can only be used with an if and not with a class declaration. These two attributes are fictional examples. See below for the standard and some non-standard attributes. In declarations, attributes may appear both before the whole declarations and directly after the name of the entity that is declared, in which case they are combined. In most other situations, attributes apply to the directly preceding entity. Two consecutive left square bracket tokens may only appear when introducing an attribute specifier or inside the attribute argument. Besides the standards attributes listed below, implementations may support arbitrary non-standard attributes with implementation-defined behavior. All attributes unknown to an implementation are ignored without causing an error. Every standard attribute is reserved for standardization. That is, every non-standard attribute is prefixed by the attribute prefix provided by the implementation. Urges the compiler to issue a warning if the return value is discarded. I think I'm gonna do a compiler. I feel like that's might be like something that'll help me understand the inner workings. A while statement caused the statement also called the loop body. A while statement caused the loop body to be executed repeatedly until the controlling expression compares equal to 0. The repetition occurs regardless of whether the loop body is entered normally or by a goto in the middle of statement. Evaluation of expression takes place before each execution of statement unless entered by a goto. If the controlling expression needs to be evaluated after the loop body, the do while loop may be used. If the execution of the loop needs to be terminated at some point, break statements can be used as a terminating statement. If the execution of the loop needs to be terminated at some point, break statements can be used as a terminating statement. Declarations right here. Oh no, wait, this is the header. This is the header. Int main void. So this is an integer type, and we're getting inside the function of main, returning a value which is nothing. If I can remember. Now we have an integer I is assigned to 2. Switch I don't know what switch I is. That's another variable. It's assigned to something. The body starts here, and I see another indentation. Case printf I is equal to 2, so execution starts at this case label. Which I. Execution of subsequent cases is terminated because they put a break right here. Print 45. Compares outputs from these two nested for loops. Compare outputs. Oh wait, these are I equals 2, so execution starts at this case label. Oh, because it equals 2, so that's why it's telling me execution is terminated. So it's going to iterate starting from printf2. For j is assigned to 0, j is less than 2. And then j is going to be incremented by 1. For I, k is assigned to 0 if k is less than 5. We have 2 loops here, 4 loops. And this is nested. I'm assuming since it's indented again, it's nested inside this for loop. So this is going to go first. Print something 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 jk j. Less than 0. Then we have another one for integer k. Only this loop is exited by the break. 45. Is equal to 2. Oh, because there's no break here. Only this loop is exited by the break. Okay, we'll continue. That was a nice little segue there. What time is it? 2 o'clock. We're almost done with 4. While loop example GCD. The following is an example of using a while loop to compute a mathematical quantity. The program computes the greatest common divisor among two user integers, num.a, num.b, and elucids algorithm. If num.a is greater than num.b, set num.a to num.a minus num.b, else set num.b to num.b minus num.a. These steps are repeated until num.a equals num.b, at which point num.a and num.b will each equal to GCD. So let's look at the input here. We have our declarations, your integers, your assignment statements, your if statements here, your if, your decision branch, and then inside your decision branch, if it's true, all these will, I'm pretty sure, go through, right? Yeah, if true, go through all of that. Elusive algorithm, don't know, but it's inside the if branch, I'm assuming, right? It's true. Not really. I think it's on its own. I think it finished the statement, the decision statement, and went on to the wild statement. So elusive algorithm is while NA is a percentage of NB greater than 0. If that is true, it will branch off to the true section and do all of these assignment statements. And then after that, I guess until it reaches something that is not greater than 0, it'll end and then put GCP and all the rest of this to the output. Right? Run. Let's take a look. It's gonna go true and then it's gonna come over here. So it only looped once and then it just went down. For the GCD program, what is the value of num.a before the first loop iteration? So for the GCD program, what is the value of num.a? Let's go to num.a before the first loop iteration. 16. blind. Oh, that's a trick question. Now it's 16. Wait. Is it? When does it become 15? Wait, am I losing it? What is the value of num a before the first? Oh, see, you gotta read. You gotta read. You gotta read more carefully. It's right here. Assume user input num a is 15. What's 15? What is the value of num a after the first iteration of the loop? B. Oh, what is the value of num a? I'm just gonna. Oh wait, hold on. I'm gonna let it do its thing. What is the value of num a after the first iteration of the loop? Looks like it's 10. The num a is greater than num b is greater than 0. The loop executes. Right? Oh, finally, I can type out programs. We got integer g. G is assigned to 0 while g is less than or equal to 4. Port g to the output. What is this, a while loop? G is assigned to 0. G to the output. And put 1. Put 2. Put 3. Put 4. Integer num mice. Num mice is assigned to 2 while num mice is less than 23. Put the output num mice, it's going to be assigned to raised to the power of num mice 2 over 2. That'll be 4. 4 times 2. Wait, 4 times 2. 4 to raise to the be 16. 16 times 2. 16 times 16. That's obviously going to be more, right? There's a space? What? Oh, because it's less than. Okay. Want me to do square roots in my brain right now? Oh my god. Numcoin is assigned 16, while 16 is greater than, put numcoin space, and now square root numcoin. 16, 8. I think that's it. Oh wait, I did that wrong. Square root, not divide. Let's do this again. 25. Numcoin. So square root of 25, 5 times 5 is 25. There you go. Put num coins 25 space, then you square root 25 would be 5. 5 is not greater than 7. Are we on cocaine or? Num coins is 5. Each iteration of the loop outputs a number. Square roots num coin. The loop repeats if num coin is greater than 7, otherwise execute proceeds past the loop. And num coins is put to the output. Oh. Because I didn't put this. My bad. Oh, my bad. Obviously it's important, but you know, I'm just trying to speed this up. I'm a little impatient tonight. I don't know why. 36 is greater than 7, so put 36. Space. Then we have square root of 36, which is what? 6 times 6. Right? 6, 12, 18, 24, 30, 36. Yeah, 6. No, put 6. I guess we'll do it, all of it. Integer samples. Integer samples, we have 10. 10 is greater than, or 10 is, wait. Num samples, while num samples is 10 is less than or equal to 5. What a trick question. Oh, here we go with the sentinel. The sentinel is pretty much just saying with an input that's gonna end the value, which is right here, right? 0 is gonna be not greater than 0. Type the program's output. Okay. Get next input, which is 6. There's no button. Oh, okay. They just want me to do it in my brain. In my brain. 6 would be user val. Maximum value would be user val. So we have 6 as user val. Maximum value. 6 is greater than 0, so it goes to true. So now it goes to another decision statement, which is user val, which is what, 6, greater than maximum value, which is 6. 6 is not greater than 6, so that's a false. So we go down to the next input. User val and get next input, so we get 7. 7. So far we have not put anything to the output. We're just grabbing inputs right now. So 7 is greater than 0, which is true. So we go to user val and maximum val. Now remember, maximum val was user val, so that was 6. So 7 is greater than 6, which is true. So now maximum value is 7, which that means it'll go down to the next input, which is 4. 4 is greater than that. 4 is not greater than 7, so it goes down to the next input, which is 9. 9 is greater than 7, which is true. So now 7 is 9. So now it grabs the next input, which is 2. 2 is not greater than 9, and 0, which it ends. Now put the maximum value to the output, which is 9. Oh, put max value. You want me to type that? Max value. I can't tell if there's a space right there. There it is. To the output. Now put 9. Okay. There you go. All in the brain. In the brain. So you have your input output statement right here. You have your assignment statements, and then you have your decision statements here. User val. This is a while loop, because it automatically just goes here to a decision statement without like having initialization of anything. Yeah, we're not doing all that. There we go. Now we're writing while loops. Finally, I actually get to write stuff. I crack my neck. All right, writing while loops. Write code that iterates while usernum is less than 13. Each iteration puts usernum to the output. Input to the output, then assigns usernum. Usernum multiplied by 3. Okay. So we have our declaration. Program will be tested with 1, 3, 5, and 13. So we have our inputs already. I'm the best. While usernum's less than 13, put usernum to the output. Put that to the output. Usernum is now assigned usernum times 3. 339, 55, 313. Write code that iterates while usernum is greater than 3. They want me to write while. Oh, wait. Okay, lowercase. While usernum is greater than 3. is greater than 3, put what? I tried to indent it, but it was like giving me an error. I don't know why. As long as I am aware of the situation, I still did it right. Write the code that assigns value sum. Write code that assigns value sum with the sum of all user inputs. User inputs is less than 0. Okay, hold on a second. Write code that assigns value sum with the sum of all user inputs. Write code that is so. Write code that assigns value sum with the sum of all user inputs. Write code that assigns value sum with the sum of all user inputs. Less than 0. Is that it? Less than 0, get the next input value user or user val 0. Let's say it's like -1, right? That'll be true. Then use val, which would be -1 plus 0, would be -1. No, 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 I did not mean to do that. I meant to hit code. I'm sorry. Luckily, I didn't see anything, but I do know that I have to type in user value. Oh my god, I can't believe I got it right. Oh my god. The loop should continue to iterate while user val is less than 0. Loop body assigns value sum with value sum plus user val to maintain the sum. do while. Clock. Oh, we're so close to finishing. And then after that, I'm gonna take like a 30-minute break, use the bathroom, and then I'll come back and see if we can do a raise for a little bit. Okay. A do while loop is a loop that first executes the song's not it. Is members only? What the really? Oh wait, this is game music. Can't listen to any video game music, that's copyright. What the I've heard that beginning part so many times. Okay, let's do it. 4.9 do while loops. A do while loop is a loop that first executes the loop body statement. Then checks the loop's condition. I'm assuming the loop's condition is the this. Compared to a while loop, a do while loop is useful when the loop should iterate at least once. So let's take a look here. The loop's body statements first, then checks the loop's condition. And it has an update statement here. It's assigned an update statement. First, the loop's body statements first, then checks the loop's condition. Because user num 4 is greater than 4, a second iteration will occur. So loop condition. Evaluates to false, goes to 0. Input? Oh. Wait, that's not an input, that's a... How to make my own do a while loop. Refer to the loop in the animation above. What is the value of Occur count after the loop. 2. Reverse iteration decrements user num to 5. What user input will prevent concur from being incremented? What would prevent concur from being incremented? Well, we're getting an input. Can't really block anything from concur from happening. By design, the do while loop iterates at least once, thus incrementing at least once. Finally, we're here. Alright, 4.10 codes or loop. In code, a loop that iterates a number of times is typically described using a for loop. A for loop is a loop with 3 parts at the top: a loop variable initialization, a loop expression, and a loop variable update. And since they keep hammering these 3 parts at me, I am definitely always going to just write it down. Even though I know it, it still helps me engrave the understanding that they want me to remember this. So step 1, if I can remember it, is the loop initialization expression. Loop initialization variable is what they call it. Loop initialization expression or variable. So I equal to 0. Then we have the loop expression. And loop variable. Okay. A loop is a loop with 3 parts at the top: a loop variable initialization. Okay, this is not it. Loop is with 3 parts at the top: a loop variable initialization, a loop expression, and a loop variable update. A for loop describes iterating a number of times more naturally than a while loop. Then it's going to tell you the code here, so let's take a look. A for loop uses the word for followed by the loop variable initialization, the loop condition, and the loop variable update. So it kind of tells you here where I is assigned to 0, I is less than 3, I will be incremented, or I is assigned to I plus 1, which is the increment. Semicolons separate the three parts, no semicolon is needed at the end. Okay, number 2, the loop's body statements. Not included. The loop variable update starts on the next line and are indented. The loop variable initialization executes once at the beginning of the loop. If the loop conditions is true, the loop body statements execute. At the end of the loop's execution, the loop's variable updates the statement is executed and the loop condition is checked again. When the loop expression is false, it goes to put a new line to the output. What are the values of I for each iteration of? What are the values of I? Wait, do I just have to? What are the values of I for each iteration of? Where I is assigned to 6, I is less than 6, I is equal to I is less than 6. Be this one, right? Starts with 0. When I reaches 6, the loop body will not be entered because 6 is false. How many times will this loop iterate? We have 0, goes 8, and then increments a month. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, sorry. You don't count 8. Loop 10 times, where I is assigned to 0. Oh, it has to be less than 9. started at 0. Yeah, that's what I did. Oh, wait, what? You want to loop it 10 times, right? So it starts with 0. So 0 goes around, 1 goes around, 2 goes around, 3 goes around, 4 goes around, 5 goes around, 6 goes around, 7 goes around, 8 goes around, 9 goes around. That's going to be looping 9 times. And that's already at 10. Ow, hold on. The 10 iterations will have I of 0, 0, 1, 2, 3, 4, 8, and 9. Okay, it might be late, but am I just dumb? Because counting started at 0, iterating with I is assigned to 10, we yield 11 iterations. Is loop 10 times. Oh, give me 1 second. That expression yields 9. I feel like I'm just dumb. I don't know why. So let's just think of this. So loop 99 times. For I is 0. Gonna be less than 99? It's the same thing. 98. 99. 0 counts as 99, so I guess that's how they see it. So loop 20 times. Because the comparison is I is less than 20, then I should start with 0. If the comparison was I is less than or equal to 20, then it should start with 1. If the comparison is I less than 20, then it should start with the comparison. Loop number of years times loop number of years times but you can put a multiplication. That wouldn't make sense. Desired number of I did not know this, to be honest. The desired number of iterations commonly in a variable. The desired number of iterations is commonly in a variable like number of years. Which do we have? Oh yes, we're almost done. So let's go with examples for loops. So for loops needs to have a loop is initialization variable, an expression, and a variable update. And then you can do loop body statements, whatever you want to put in. Following program outputs the amount of savings account each year for 10 years. The loop iterates 10 times, such that each iteration represents 1 year, outputting that year's savings amount. Consider the example above. How many times does a loop iterate? So let's just do it with our mind instead of doing it with the steps. How many times does the loop iterate? So let's take a look here. We have our floats, we have our integer, initial savings is getting next input. We honestly know that the initial savings is 10,000. And the next one is 0.05. Put annual savings for 10 years at the output, so they're just going to write that down in the string. And we have our assignment statement, which is current savings is assigned to initial savings. So current savings right now is 0. It's assigned to initial savings, which is now 10,000. I is over here, so we have our declaration for I as an integer. Now we're getting into our decision statement, which is a for loop. So for I is equal to 0, I is going to be less than 0, which is true. So that means we're going to put a dollar sign to the output. We're going to put the current savings to the output, which is the initial savings. which is 10,000. So it's going to put a dollar sign with 10,000 and start a new line to the output. And then they're going to reassign current savings with current savings plus current savings times the interest rate. So it's going to multiply 10,000 with 0.05. And then that's just going to increment over and over. And so how many times it's going to do that? I can do the multiplication, but let's, considering that we kind of know what's going to happen, let's just see how many times it's going to do it. So it increments 1. I1 is less than 10, so it's going to go again. So that's 2. Go again, 3. 4. Can we go faster? 5. 6. I'm just gonna skip. So it iterates 10 times. During each iteration, the loop's body statements outputs the current savings amount and then it updates the fourth statement, and then it updates the +1. Incrementing is after the update. As I is assigned to I+1, execute at the start or the end of the loop body. The end. Many times does the loop variable initialization? Wait, how many times does the loop variable initialization I assign 0 execute? How many times does the loop variable? Oh, once. Because it's the start, and that's the only time you ever get to touch it. If you look at the flow chart, you'll see it's on its own right here. Little trick question. Computing the average of a list of input values. The example below computes the average of an input list of integer values. First input indicates the number of values in the subsequent list. That number controls how many times the subsequent for loop iterates. First input indicates the number of values in the subsequent list. The first input indicates the number of values in the subsequent list. So there's going to be 4 values in the subsequent list. So it starts with 4. The input. So num values is going to be 4. And then so that's what's going to be on the list there. So I is going to be 0 is going to be less than 4. And then it's going to do all this computing. Before the loop is executed, what is the value sum? Before the loop is executed, what is the value sum? It's assigned to 0. I feel like that's a trick question, but it's not, I guess. Appears just before the loop. Some of the values seen so far is 0. because no values have been seen. So, gotta make sense, right? Number two, what is value sums after the first iteration? We look at value sum, which is 0. No value, so I is 0, so I is less than 4, which means current value is going to be the next input, which is 10. Current value plus value sum, which is 0. So that'll be 10. So value sum is 0, or sorry, value sum is 10 right now. And then it's going to increment. And value sum was initially 0. The first iteration gets 10 from the input and executes value sum plus that assigns it 0 and 10. And then it's going to do all that. So I'll let you guys do all the other ones. We'll just continue on with this. For loop versus while loops. Although for loops and while loops can achieve the same computation, to enhance program readability, programmers should use for loops when the number of iterations can be easily calculated beforehand, and while loops otherwise. A for loop is just a compact, easily readable form of a common while loop pattern. The initialization precedes the loop expression, and the update is the last body statement. Okay. To improve program readability, programmers use a for loop when the number of iterations is calculable, such as iterating user num time. Otherwise, programmers use a while loop, such as iterating until a user enters 0. Choosing to use a for loop versus a while loop. Iterate 100 times. Which loop is preferred? A for loop. For I is equals to 0, I is less than 100. Increment every time, one time. Iterate as long as the input is a non-negative integer. Which loop is preferred? It's a while loop because we don't know the number. Programmer doesn't know what input will appear, so the input is what matters. We don't know the input. As long as the input is non-negative, we'll just do a while loop, and that should be good. Given user num that was gotten from the input, iterate user num times which loop is preferred. We still don't know the number. It's gotten from the input. So, oh, the programmer doesn't know. Oh, it's a variable that has a number inside. Okay, doesn't know. Although the programmer doesn't know the actual value of user num, the programmer does know the loop will iterate user num times. The loop will iterate. Because there's a number in here that we don't know, but it's still a number that will keep iterating until that number is reached. Given user num that was gotten from the input, assign user num with user num divided by 2 and output the result. Stopping after the result is less than 10. Iterate number of times. 9 divided by 2. Number of iterations is not easily calculable beforehand, thus use a while loop. Because we don't have a statement to calculate it, so we don't know what to calculate it with. God, from the input, assign user num with user num divided by 0 and output the result. Stopping after the result is less than 10. While user num is greater than or equal to 10. Number of iterations, not calculable. Just trying to see how someone go about that. Because I'm looking at number 3 and number 4. Given the user num that was gotten from the input, iterate number of times. So the only reason why we know it's a for loop is because there's a thing that says iterate number of times. But I guess I need a better example. Instead of it telling me that it's going to iterate a number of times, I guess I should look at a problem that it'll let me see it as, okay, so this user num is going to be iterated a number of times. I won't stress about this. Maybe another time I'll probably run into it. All for loops can be written as equivalent code involving a while loop. All for loops can be written as equivalent code involving a while loop. Don't we have that? I feel like we had that. All for loops can be written as equivalent code involving a while loop. All while loop expression is true. All for loops can be written. I want to say that's true. A for loop is just a compact form of a common while loop pattern involving a variable initialization before the loop and a variable update as the loop body statement, as the last loop body statement. A programming language does not need to have a for loop, but most include for loops as convenient. Nice. Type the program's output. That'd be 3 o'clock. Oh my god. Integer I for I is assigned to 0. 0 is less than 4. Increment I to the output. 0 is 1, 2, 3. For I, 0 is less than 2, but I times 2, so it'd be 0 times 2 would be 0. Now plus 1. 1's less than 2. 1 times 2 is 2. Plus 1. Be done. Write a for loop that iterates 6 times. Okay. For I is assigned to 0. Each iteration put user num output. Okay, and it iterates 6 times. Oh, we know the iteration. 6. Each iteration put user num to output. Then put to output. Then assign user num if user num multiplied by 4 and that should be fine because now we have the increments here. Oh my god, beautiful. Beautiful, beautiful, beautiful. For loop that iterates 6 times can be achieved via for loop. Alright, Alright, next. Give me another one. Give me another one, baby. Another one, baby. For loop that iterates a for loop, so it's going to be for I equal to 0, I. For a loop that iterates num dashes times. Okay. Num dash each time each iterations put to output. Num dash is user num. Program will be tested with inputs 4, 6, and 1. I feel like I did this wrong, but the desired number of iterations is in the variable. To iterate num dashes times, a for loop may assign I with 0. Iterate while I is less than num dashes to evaluates to true. And assigns I with I plus 1. The loop puts a output. So user num was just a trick to fool me. But I'm not fooled. I'm not fooled. Just trying to second guess me. Write a for loop, so obviously right off the bat for I. Write a for loop that iterates total num times. On each iteration, assign user num with the next input. Then put put user num to the output. Put to output. They wanted me to do that. Back. Easy for loops. To iterate total number of times, a for loop may assign to I with 0. Iterate while I is less than total number, and assign I with plus 1. The loop body assigns user num with the next input. 2. I'm just trying to look at it, look my answers, and then I'm just plugging it in so I can understand it a little bit more. Iterate total number of times. A for loop may assign I with 0. Iterate while I is less than total numbers. And assign I with I plus 1. Loop body assigns user num with the next input. And puts user num to output, then puts okay. Okay, write a for loop. So for iterates num age. Each iteration assign user age with the next input. Then assign sub result. Input. Easy. Loop summary. I guess I'll read it. A loop is a program construct that repeatedly executes the loop statement. The construct that repeatedly executes the loop statement, loop known as the loop's body. While the loop's expression is true, when false, the execution proceeds past the loop. Each time through a loop statement is called an iteration. Okay. Common programming task is to use a loop to examine a list of values, one value at a time. Okay, programmers often use loops to execute a computation until a done condition is clear. That done condition is reached when the loop expression is false. An infinite loop is a loop that never stops iterating. A loop iterating a specific number of times commonly consists of 3 parts: a loop variable initialization, they're talking about a for loop here, a decision statement for the loop expression, and a loop variable update at the end of the loop body. A while loop is a loop that repeatedly executes the loop's body. A while loop is a loop that repeatedly executes the loop's body while the loop's expression evaluates to true. For loop is a loop that typically describes iterating for a specific number of times. A for loop consists of a loop and variable initialization, like I said earlier. A nested loop is a loop that appears in the body of another loop. The nested loops are commonly referred to as the inner loop and outer loop. A do while loop is a loop that first executes the loop's body statements, then checks the loop's condition. Compared to a while loop, a do while loop is useful when loops should iterate at least once. Oh, cool. We have questions here. Let's do these and then convert to binary. This lab is wild. Lab's like, alright, since you know while and for loops, time to convert binary, boys. I'm doing pretty good. We're pretty much done. I just want to do the loop summary, see how I'm doing so far. A program should output even numbers from 2 to 50. Which control structure should be used? Control structure. Well, we know that it's not if statements because I don't think statements are a structure. If not, that's the biggest trick question I've ever heard. But let's take a look. A program should output even numbers from 2 to 50. So it should output numbers from 2 to 50, which means that there is a number where we know it's going to stop, right? So it's going to be a for loop. We have a specific number. The number of iterations is computable, which is 50, before the loop executes. So a for loop can be used to iterate the fixed number of times. A program should continue getting an input and converting that value from pounds to kilograms until the input is 0. I think the big key word is should, because that tells us that we don't know the program is going to be ending, right? But it should be done once it reaches 0, right? That's a while loop. I'm understanding your guys' language, okay? A while loop is used when the number of iterations is not computable before the loop. The number of iterations for this program is not computable because the number of iterations depends on the user's input. A program first assigns user num with a value read from user input. So what does that tell you? It's going to be a while loop. Or maybe a do while. Let's see. The program outputs the value of user num and adds 1 to the user num. Then if the user num is less than 100, the program repeats, outputting the value of user num, adding 1 to user num. So that sounds like a do while loop right there, because it started executing one time and then it reached towards the end, which is a decision statement. If, right? But if at the bottom. So if you think of like a flow chart, the decision statement will be under the iteration of the loop body, which will be the last step, right? Before it goes to false. What is put to the output by the following pseudocode? What is put to the output? X is assigned 10, X is greater than 4, put X, so it's going to be 10 with a space. Minus 2 will be 8, 6, and then 4 is not greater than 4, so it's going to be that. What is the loop's condition expression in the following pseudocode? I is 5 while I is less than 5. While this one, loops executes while I is less than or equal to 25. I was just thinking about something here. What is the loop variable initialization in the following pseudocode? Variable initialization. Ooh, that's a trick question. Why is involved? Because if this said X, I would have went with X 0, but it says Y, so the variable Y is used to control the loop execution. Okay, there we go. And it's initialized with 10 before the loop. What is the loop's variable update statement in the following pseudocode? That's easy. Alright, we're done with chapter 4. Did I do this? I never did this. I just want to take a look. I'm not going to do it, but I just want to take a look. Write a program that takes in a positive integer as an input and outputs a string of ones and zeros representing the integer in binary. For an integer x, the algorithm long as x is greater than 0, output x, remainder is either 0 or 1. Above algorithm outputs zeros and ones in reverse order. Whoa, this is a little bit hard. I'm going to convert to binary. Write a program that takes in a positive integer as an input. I want to do this, but I feel like it's going to be too hard. Integer. Write a program that takes in a positive integer as an input and outputs a string. So it wants me to put in integer. Input. Positive integer as the input. How do I convert it to binary? I mean, I know it starts with 0. Well, it starts with 1, right? And then it starts with 2, and then it doubles over time. I know that. But how do I double it? Or how do I convert it? So if I have a 2, 2 would be 1, 0. So how do I make a 2 into a 10? No, wait. 20. 16 times 2, 32? No, that's not right. 16 times 16? 16 times 16? 36? 16 times 16? Am I just... God, it's late. 16, 6, 12, 18, 24, 30, 36. Yeah, 36. Right? 3, 4, 5, 56. Okay. Um... What is 2? The number 2. Number 2 is going to be right here. So that's going to be a 1, 0, 0, 0. Now, how am I going to convert number 2 into a 10? Count that as a binary number. How did they convert it? Oh great, just turn off all my, minimize everything, why don't you? Where's my calculator? I just want to see if what they're doing is true. Long as x is greater than 0. Output x greater is either 0 or 1. So if it's 2, two is percentage 2, remainder is either 0 or 1. The above algorithm outputs zeros and ones in reverse order. Okay, but I found out x, if I put this calculation, if I put 2, percentage of 2, that will give me 1. But you have to understand that this is a number. It's going to be in the ones place instead of the zeros place, so I need to fix that in reverse order. I'm gonna have to cheat. Teach me about converting loops to binary, buddy.
Loop labs, and this starts our week 3 labs. Make sure that your
Oh wow, it's the same question.
x is greater than 0. The output is x modular. We go over that.
Oh, modular. I forgot about what modular does. Modular just you're only focused on the remainder, right? For modular?
This is what this so-
1,
1, and then x equals x divided by 2. The above.
Like, I understand what they want me to do here, but x is the sine x divided by 2.
Algorithm outputs zeros and ones in reverse order. So you can start with input of 6, and the output is 0, 1, 1, which is in binary. Okay, so 6 in binary is 1, 1, 0. The algorithm outputs the bits in reverse. Okay, to show you that there. So very important now, and we've used this operator before, basically dividing to see if you have either a 0 or 1 as a remainder. So very important that note that's not a division, but that is the modulo statement there. Okay, so your solution is going to go here. So I say integer is username gets next input. While, so we're using a while statement here.
Number get user not greater than 0.
And then executing while statement, the next lines are indented 3 spaces there. So if the number is greater than 0, I'm going to put modular value.
But why is it getting greater than 0? Is he just doing this?
To output, which is either going to be that 0 or 1, and then that user number is equal to user number divided by 2. Okay, so I'm going to put my input of 6, and I expect the output there, 0, 1, 1. And run it. As you see, it's stepping through the code there, and it changed that. So the while statement went through, right, 3 times. You saw a decrement there each time, and got my output of 0, 1, 1, which is expected. And now I'm going to submit for grading.
We did user num. All he did was copy this. So he has his own integer, which is user num. Get next input. He did a while loop as long as, because it says, the first sentence says, as long as x is greater than 0. So there's no for loop being involved here. It's more or less as long as x is greater than 0, because we don't know what the value of x is. It could be anything. Output x modulo 2 modulo, that would give us the remainder of 0 or 1, because modulo is for the remainder of division, of dividing. And then that, so while x is greater than 0, put x modulo 2 to output, and assign x with x divided by 2. I think that's about it, right? For example, if we put a 6, we should get oh, my bad, integer. lot of good thing that I'm double checking. I need to get 011. Good thing I can remember. Okay, so all he did was just read the question and just copy this. He just did this. That was a lab. I should not have done that, but I guess I did it. I was literally about to go like, let's do some binaries real quick. Did one lab. Now we are in the arrays, which is pretty much, I think, just loops that we were just doing. It's just arrays is just a better understanding of like list or stuff. But what time is it? Jesus, 3:30. I gotta use the bathroom. I'll be back. Okay. It's pretty late. What I'm gonna do is I'm gonna go to sleep. Maybe 4 hours. I'll be back on in 4 hours, so 8 o'clock. Maybe that. Between 8 and 10, I'll be back, and we'll continue on. I am tired. I'll see you guys in a couple of hours.